Okay. Good morning, student. I Vikas Sharma once again with you. Yesterday we have discussed about polynomial and term related to polynomial. But today we will discuss about the question based on polynomial of NCERT. Okay. Now see, in this NCERT exercise 2.1 we will discuss about exercise 2.1 of polynomial and it has graph. Now see, firstly we will understand the concept about the graph and geometrical meaning of the graph. Okay, then see, firstly we draw a horizontal line. Okay, this horizontal line is known as x-axis and this is the another, sorry, this is the something mistake. Okay, see, this is the x-axis horizontal line and this is the our vertical line. Okay, see, this is our x, positive side of x, and this is negative side of x, that means x dash, and this is the y, and here is y dash. Okay, this is y dash. Now see about the geometrical meaning of this graph for the polynomial, है ना? See, suppose that any polynomial, suppose that this is the our graph. Okay, this is the our graph, and see, if this is the graph of, if this is the graph of y is equal to px. Okay, y is equal to px, this is the graph of y is equal to px, then see the how many times this graph intersect of y axis. This is only one times. Then number of zeros for this graph is 1. We will count the number of intersection of this graph on x-axis. That will be our answer. Okay, now see the question number first for this graph. Okay, see, in this graph it is as like this. Okay, question number firstly see the what says question. Question says the graph of y is equal to px are given in figure 2.10 below. For some polynomial px, find the number of zeros of px in each cases. Number of zeros of px in each cases. Clear? Now see, graph is as like this. Our graph is as like this. Question number first. Okay, this is the question number first which we discuss. This is the our axis and this is the our graph. This is parallel to this. Okay, this line is parallel to this, then this line is no intersecting on x-axis. Okay, this graph is not intersecting of x-axis, so number of zeros should be 0. That means no any 0 for this, no any 0 for this x-axis. That means we will write the number of zeros is, we will write the number of zeros is 0. Okay, number of zeros is zeros as the given graph. Okay, as the given graph. Clear? Okay, next question we will see. Question number 2. Okay, we will see question number 2. Question number 2. Question number 2 is graph as like this. Graph is as like this. This is the our x-axis, this is the our y-axis, and this is the graph. This is the graph. From here starts these types. this types and is goes to this type. Okay, this is the our graph for second question. Then see number of y-axis intersected. How many times y-axis intersected by this graph? Then it is only one times. Yes, only one times. Then number of zeros for this graph. What we will write? Number of zeros for this graph. Number of zeros for this graph is 1. Yes, that means this graph is intersected by only one times by this x-axis. Then this is the 1 zeros for this polynomial. Okay, now second. Now second, sorry, third. Third one is, what is the third? Yes, these types of graph is third. This is the x-axis. This is the this is the y-axis. Okay, and the graph is starting from here and goes as like intersecting and this. Okay. Okay, question is that how many zeros of this polynomial? Okay, then see we will count the intersecting point of x-axis and this graph. Okay, we will count the intersecting point and x-axis. This is the one point. This is the second point where graph and x-axis intersect, and this is the third point where our graph and x-axis intersect. That means each graph is intersected by 3 times. How many times? 3 times. Then number of zeros for this polynomial is 3. That means this graph is intersected 3 times by the x-axis. So number of zeros for this polynomial is 3. Okay, now we will see the question number 4. Question number 4. 4 is again very simple. 4 is again very simple. This is the our x-axis, y-axis. This is the x and this is the x dash. This is y-axis and this is our y dash. Okay. Now graph is as like this. This type. Okay, this type. है ना? But we have to count zeros, number of zeros for this polynomial, for this graph. Okay, then concept is that number of times intersected by the graph by the x-axis. Then this graph is intersect x-axis in this point and at this point. That means 2 point. On the 2 point this graph intersected. That means number of zeros of this graph is how many times? 2. 2 times intersect the x-axis, then number of zeros is 2. Okay, now see question number 5. Question number 5. Okay, see the question number 5. Question number 5 is once again very simple. This and if this graph start from here upward downward and again intersecting by this and this. Clear? This is the our graph. We have to decided number of zeros for this polynomial. Then concept is only that number of x-axis cutting by this graph. Then see Number of x-axis cutting by this graph is, this is the first point, this is the second point, this is the third point, and this is the fourth point. That means we will write number of zeros for this graph is 4. That means 4 times cuts the x-axis. Okay, then number of zeros for this polynomial is 4. Okay, next question number 5. Question number 5, and question number 5 is as like this. This is the x-axis, y-axis, this is the x-axis. Now see, this is our x-axis. Okay, this is our x dash, this is y-axis, and this is our y dash. Okay, see, the graph is as like this. Graph is as like starts from here and only touch and goes upward, and then once again only touch and goes upward. Okay, only touch at this point, this is only touching point. Clear? Then see, number of zeros for this graph y is equal to px. Okay, this is y is equal to px. Then see how many times this graph intersects the our x-axis. Either we can say intersect or touch. Yes, this is the second touching point and this is the third touching point. Okay, then number of intersecting as touching point of this polynomial of this graph is 1, 2, 3 times. Then we will write number of zeros for this graph. Number of zeros for this graph is 3. Okay, 3. That means it is touching 3 times of this x-axis, then this is the 3 times 3 zeros. Okay, now we have discussed about all the question of exercise, first, sorry, 2 first. Okay, this is the class 10 exercise 2.1. we write exercise 2.1 of and C, sorry, and CERT books. This is the first question, first exam exercise of 2.1. Okay, see, this is complete solution of your exercise. Now we will discuss about next point. Okay, and next point is, our next point is zeros of polynomial. Okay, this exercise is completed. Okay, this exercise is completed. Okay, it has only 6 questions and all the question we discuss about, we discuss. Now our next point is relationship. Okay, relationship between zeros and coefficient of the polynomial. Okay, relationship between coefficient and zeros of a polynomial we have to read now. Okay, then see, firstly we discuss about in this new section page. Okay, see, okay, okay, now see, we draw a line and now we start relation between zeros and coefficient of polynomial. Okay, polynomial. Okay, now see, now see, suppose that this is the polynomial in term of x. This is our polynomial in term of x, and we discuss about quadratic polynomial. What quadratic polynomial? Suppose that 2x squared plus 8x minus 7. Suppose that it is our polynomial. Okay, suppose it is our polynomial, and we discuss about some questions, some concept for this polynomial. Okay, okay, now see, firstly we should know about zeros of this polynomial. Zeros, that means for what point of x. Okay, see carefully, for what point, for what value of x, for what value of x, what, listen, for what value of x, the value of px is 0. Yes, for what value of x, for what value of x, the value of our polynomial px should be 0. That will be the 0 of polynomial. Okay, now see, zeros of polynomial, zeros of the polynomial depend on their degree. Yes, zeros of polynomial, zeros of polynomial is depends on their degree. Listen carefully, degree. If you have polynomial of degree 2, then their maximum number of zeros, what, maximum number of maximum number of 0 will be 2, है ना. It may be 1, it may be 2, है ना, and also it may be no any 0 of this polynomial. But if we talk about maximum number of 0, then it is clear that maximum number of zeros is equal to their degree. Okay, maximum number we are talking, but it may be the zeros will be less than their degree. Okay, okay, now see, once again, suppose if we talk about our polynomial px, and px is x square minus 2x minus 8, then just we know this is the polynomial of degree 2. This is the polynomial of degree 2. Okay, this is the polynomial of degree 2. Suppose that it has 2 degree. Okay, it has 2 degree. Suppose first degree we say that alpha and second one beta. Yes, suppose it has first degree is alpha and second degree is beta. Yes, then the relation between the coefficient and zeros will be, relation between coefficient of zeros will be, first of all we will write sum of zeros. Okay, sum of zeros will be coefficient of minus coefficient of x by coefficient of x square. Okay, coefficient of x by coefficient of x square. Then we will write sum of 0, that means we have zeros alpha and beta. Okay, alpha and beta. Then we write alpha and beta equal to our coefficient of x square is minus 2 minus 2. Okay, this becomes minus and minus 2 by coefficient of x square is 1. Then sum of alpha beta is 2 by 2 by 1, that means only 2. And second one we have product of zeros, है ना, product of zeros. Okay, product of zeros, it is constant term. What? Constant term divided by coefficient of x square. Constant term divided by coefficient of x square. Which is our constant term? Our constant term is minus 8. What? It will be minus 8. Okay, now see, product of 0, that means alpha into beta. Alpha into beta is equal to constant term minus 8 by 1. This means minus 8. Clear is this? But this is the one example. Okay, now see the full concept of this polynomial. Okay, see, suppose that if we talk about quadratic polynomial, yes, quadratic polynomial. Clear? Suppose we have to talk about quadratic polynomial. Okay, now see, this is, suppose that general form of quadratic polynomial. Yes, general form of quadratic polynomial is ax squared plus bx plus c. This is our general form of quadratic polynomial px. Condition is that a is not equal to 0, okay, and a, b, c are constant. Okay, a, b, c are constant. Okay, a, b, c are constant. This is our reference. Okay, now see, if we talk about coefficient of x, then coefficient of x is b, coefficient of x square is a, and this is our constant term. This is known as constant term. This is coefficient of x is b and coefficient of x square is a. Okay, now the first relation between coefficient and zeros, then this is the sum of zeros. Okay, sum of zeros. Sum of zeros is minus coefficient of x coefficient of x divided by coefficient of x square. That means we can say alpha plus beta is equal to minus b by a. Okay, this is the our first formula for this exercise. Okay, and second one, product of zeros. What? Product of 0. Product of zeros. This is the product of zeros. Yes, product of zeros for this polynomial is constant term. What? Constant term divided by coefficient of x square. Then it becomes product of 0, that means we have zeros alpha and beta. Okay, alpha into beta is equal to, which is constant term, c, and coefficient of x square is a. Then this is the our another relation between coefficient of zeros and coefficient of zeros and zeros. Okay, now see now we will discuss about a question based on this theory. Okay, then see example 1. What? Example 1. See, suppose we take an example of 3x square minus x minus 4. This is the our polynomial in term of x. This is our polynomial, and firstly we have to find, है ना, we have to find we have to find their zeros and verify also, है ना. That means we have to find their zeros and verify the relation between coefficient and zeros. Then how we will find? Okay, then see, we will write this is the our px is equal to 3x square minus x minus 4. Okay, now see, firstly we will multiply this term by this term. Okay, means we will multiply this both term, then it becomes minus 12x square. Okay, minus 12x square. Now we will factorize this 12. Okay, then it becomes 2 times it comes 6, again 2 times it comes 3. Okay, now 3 times it comes 1. Okay, then our factor will be 2, 2 and 3. We have to break this term in two parts. We have to break these terms to two parts such that their their sum is minus x. Their sum is minus x. Okay, sum is x and product is 12. Okay, then see, if we break this part 3x square, this is as like this, and this become minus 4x plus 3x minus 4. Then this is the our required, clear. Okay, next we will take the comma from these two terms. Okay, we will take the comma from these two terms, then common will be x. Okay, now here 3x minus 4, 3x minus 4, and this is plus, then comma is no anyone, then we can take 1 as a common. Okay, we can take as 1 as a common, then this becomes 3x minus 4. Now again 3x minus 4 again common, then it should be x minus x plus 1. Okay, now see, for finding the zeros of this polynomial. Okay, now see, for find zeros of this polynomial px we have laid that px, then px should be 0. What px, what will be the value of px? Px should be 0. Okay, then just we break that px in as like 3x minus 4 and x plus 1. This becomes 0. Now see, product of this and this is 0. Yes, see, product of this and this is 0. That means product of two number is 0. See here, suppose that product of a and b are 0, then either first number will be 0 or second number will be 0. Condition for that, if we multiply 0 into b, then also 0, and if we take a into 0 also 0. That means if product of two number is 0, then that will be either first number 0 or second number 0. Okay, either first number 0 or second number 0, then that will be 3x minus 4 equal to 0, or x plus 1 equal to 0. These two cases will be here. Okay, if this term will be 0, then 3x is equal to 4, and yes, and x is equal to minus 1. Once again, this becomes x is equal to 4 by 3, and this will be x is equal to minus 1. Okay, now we will write the zeros of this polynomial. We will write zeros of this polynomial is 4 by 3 and minus 1. Now we have to verify that means on the based on relation between coefficient and zeros. Yes, now see, for verify, as you know, suppose that this is the first zeros and this is the second zero. Okay, this is the first zero and this is the second zero. Then we will write sum of zeros. Okay, sum of zeros. Sum of zeros will be 4 by 3 and plus minus 1. It becomes 4 by 3 minus 1. Then take LCM as a 3. 4 minus 3, this become minus 3. Okay, this become minus 3, that means 1 by 3, and we know 1 by 3, this is the sum of 0, that means minus coefficient of x divided by coefficient of x square. We can see our questions. Okay, now see another product of zeros. Okay, product of zeros. Okay, product of zeros will be, our zeros is 4 by 3 and minus 1. It becomes minus 4 by 3. Okay, now this will be, product of zeros will be constant term divided by coefficient of x square. This is the our complete solution with verify. Okay, now I am giving you some homework to you. Okay, first one is 3x square plus 12x plus 3x square plus 12x minus uh, minus 8. Try to find their zeros and verify that. Okay, and also verify that. Okay, and now again your homework should be exercise 2.2. Question number first. Question number first is all based on this concept. Okay, thank you.